In this section of notes, we want to look a little bit at inference. So inference means what kind of conclusions or generalizations can you make? So when we're doing experiments, sometimes we'll see a difference and we have to decide whether or not we think that difference is statistically significant or it's just sampling variability. So sampling variability, you'll remember that from earlier, that just means that every time you take a sample, you expect to get a slightly different result. So let's say I was going to flip a coin 100 times. Now, theoretically, you know that you have a 50-50 chance of either getting a heads or a tails, so you would expect to get something close to 50 heads every time you go through the process of flipping a coin 100 times. Now, you wouldn't really be surprised, though, if one time you got 49 heads and another time you got 51 heads. So those are examples of sampling variability, where you don't always get the exact same answer, but they're not statistically significant. So it's not that unusual to get 49 or 51 heads instead of the 50 that you expect. So what we're going to look at is how often something happens just by chance and what makes it statistically significant. Now, depending on the consequences of whether or not something happens by chance, we will change what it means to be statistically significant. So the most common outcome or cutoff is 5%. So if we have evidence and we say that this is going to happen purely by chance less than 5% of the time, then we say it's statistically significant. Now, sometimes we'll use a 1% or even a 10% cutoff, but 5 is the most common. So if the consequence of you being wrong is that maybe someone gets very sick or there's a very serious consequence, then maybe you'd want to bump down to the 1. You wouldn't want that to happen very often. But if the consequence is less serious, like maybe someone buys a little extra toilet paper at the grocery store because they misthought about how much they would need, well, then that's not quite as serious because maybe they can use that toilet paper later. So maybe you'd bump up to 10% on that case. So again, these cutoff values are somewhat arbitrary, but they're the most commonly used. So 5% is the one we use most of the time. If something is pretty serious and has serious consequences, we might bump down to 1. If it's a little less serious or the consequences aren't so bad, maybe we'd bump up to 10. So you'll see these 3 as the most common significance levels used. Now, one other thing I want to mention to you is just the idea of your margin of error. So where we were talking about flipping coins and we would expect to get 50 heads if we flip the coin 100 times. Your point estimate might be 0.5 because you expect 50% of the time to get a heads or a tails. Your margin of error would be something that you add to that 0.5 that you think is reasonable. So do you think it's maybe reasonable to flip a fair coin and get anywhere between 40 and 60% heads? Then maybe your margin of error would be 10%. So there's a formula for margin of error, and we'll come back to it later. But just know that this value that you expect here, or maybe you got in a sample, is called a point estimate. And then the amount that you might be off, give or take, that's called your margin of error.